Example 6. Write a linear function g with the values g of 2 equals 3 and g of 6 equals 5. Now, in order to do this, we have to remember what this is actually telling us, what function notation is actually telling us. So if we're saying g of 2, remember that 2 is your input, which also represents your x, and then 3 is your output, which represents your y. So really what you have here is you have a point, and you have the point 2, 3. Then if you look over here, you have g of 6 equals 5, which is also telling you you have the point 6, 5. So now, once we know that we have 2 points, we have to write a linear function g. So I'm thinking point slope form. Well, we have 2 points. Now I need the slope. So remember, slope is represented by m, which is your change in y over your change in x. If I'm going to do my change in y, I have a 3 and I have a 5, so I'm going to do 5 minus 3 over my change in x, which I have a 6 and I have a 5, or I'm sorry, a 2, so 6 minus 2. 5 minus 3 is 2. 6 minus 2 is 4. If we simplify, we have a slope of 1/2. Now, if we're doing point slope form, that's y minus y1 equals m times x minus x1. You can pick either point. It does not matter. I'm going to pick the 2, 3 because it has smaller numbers. I like 2 and 3 better than I like 6 and 5. But again, does not matter. So this is going to be my x. This is going to be my y. Y minus the y value, which is 3, equals my slope, which we found was 1/2, times x minus the x value, which is 2. Now, in the directions, it does not say that this has to be in slope-intercept form. It does not say that it has to be in standard form. It doesn't say anything. So it just says write a linear function g. Now, that's where the problem's coming in, is they want a function g. So that means I have to get it into g of x equals. Well, in order to do that, we do actually have to put this in slope-intercept form. So let me show you what I mean. First of all, I'm going to distribute my 1/2. So I'm going to have y minus 3 equals 1/2 x minus 1. Then I'm going to add my 3. So y equals 1/2 x plus 2. Now that's beautiful, but I want a linear function g, which means it's g of 2 has to be 3, g of 6 has to be 5, which means instead of a y value here, we're going to replace that with g of x. So let me just bring it up here. G of x equals 1/2 x plus 2. Then, just a real quick check. Do you guys remember we had g of 2 equals 3? Which means if I substitute 2 in for x, I should get 3. Well, let's look at that. 1/2 times 2 plus 2. 1/2 times 2 is 1, plus 2 equals 3. So my function checks out. Example 7. Write a linear function g with the values g of 0 equals 9 and g of 8 equals 7. Same thing, we're just going to practice it again. So my first point is 0, 9. My second point is 8, 7. This is your x, this is your y. This is your x, this is your y. The first thing I'm going to do is find my slope, which is the change in y over the change in x. If I find the change in y, I have a 7 and a 9. So 7 minus 9 over 8 and 0, 8 minus 0. Negative 2 over 8 is negative 1/4. Now again, I can pick any point I want. This time, I'm definitely going to pick the point that has the 0 in it, because if you notice, 0, 9 is actually the y-intercept. So if I have the y-intercept, this is telling me that my b value is 9. So this time I can go straight to y equals mx plus b because I have my y-intercept. So y equals negative 1/4, that's the slope that we found, x plus 9, because that's my y-intercept, and this is pretty much my function. The only thing is that it has to be a function g, so I need g of x. So take your y, change it to g of x equals negative 1/4 x plus 9, and there's your function.